Hey everyone, welcome to the Happy Flosser podcast. My name is Billy Lunt. I am your host, and I am here to talk to you about all things dental hygiene to support you on your journey through the dental hygiene program. Welcome, so glad to have you. Hey, are you in dental hygiene school or just got your acceptance letter and just started dental hygiene school and you're worried about how you're going to fit it all in, what the evaluations are like, what the key strategies you need to set up in order to be successful? You don't want to have worked all this time to get accepted into dental hygiene school only to make some pretty major errors in your first and second semester. I've put together a course that will really help you set yourself straight right out of the gate and get yourself started on the right foot in dental hygiene school. Whether or not you're just entering school or you've done your prerequisites and you're just well on your way halfway through, this course is designed to help get you straight and keep you straight so that you can become a dental hygienist. Click the link in the show notes and check it out. Hey everyone, in this episode, we're going to be talking about biostatistics in the field of dentistry. So what is biostatistics? It's a branch of statistics that's responsible for the proper interpretation of scientific data or data, depending on where you live, that's generated in biology, public health, and all of the oral health sciences, basically. And it allows for data to be quantified. So that's what we're going to be talking about in this episode today. It's really important that you have a basic understanding of the different components of biostatistics because these questions about biostatistics will show up on your board exams. Even more important than that, everything that we do in dentistry is evidence-based. So you need to be able to interpret information. When you look at research articles, you need to find out the validity of that data that you're looking at by understanding the biostatistics and the p-values. And we'll talk about all of that in this episode. Are you looking for study sheets? I've created study sheets that cover the content of this episode. If you're interested or that's something that's going to help you on your learning journey, you can click the link listed right in the description of these show notes. Happy studying! There's basically two different types of data. You have descriptive data, and then you have inferential data. So let's first talk about descriptive data, and that's the data that you currently have. And you can summarize the data based on a sample. It helps show relationship among different variables or correlation. If somebody's using a specific flosser, does that improve gingival health? Just for example, there's all kinds of different descriptive data where you can do correlation between. Measurements are either nominal or ordinal, and we'll talk about that. It consists of procedure used to summarize and organize descriptive data. So we're talking about measure of central tendency, measure of dispersion, frequency distribution, percentiles, correlations, and we use tables and graphs in order to give us a visual understanding of descriptive data. The bell curve is probably the most common used descriptive data visual table or graph that can be decided. Inferential data allows you to infer what might happen to a population based on a smaller sample. And most research does include smaller samples when you're talking about different types of clinical data. The focus would be on ratios or interval scale. Now, the larger the sample size and the more randomized the sample size, the greater the generalization is to the general public. The larger samples can use ordinal or discrete, which is less common, data. Remember, with inferential, the population is normally distributed, so the bell curve will typically be your result when you're talking about that. Now, there's two different types of inferential statistics. There's parametric, which is interval or ratio, and then there's non-parametric, which is nominal or ordinal, which creates the assumption component of how the data is inferred. And this is always preceded by descriptive data. So you start with the descriptive data, the current data that you already have, and then you will use inferential data to maybe fill in the gaps on something new or something you've discovered. Now, when you're talking about graphic data, there's different types of graphs that you use. And graphic data provides visual aids in order for us to make it easier for not only ourselves, but for others to understand the results of our data gathering. Now, a bar graph is used to display frequency of nominal and ordinal data, or that are discrete in nature. So it's used to help us represent categorical data, and the length of the bar would correspond with the frequency, just as an example, when you're talking about a bar graph. And I think you can visualize what a bar graph looks like. Now, a histogram is similar to the bar graph, but the bars are side by side. They're actually touching, so there's no grouped categories there. And this is used for interval or ratio variables. It helps us with ordinal data that is treated as continuous in nature. Then we have what's called a frequency polygon, which is a line graph, and it's used to group or ungroup frequencies. And it can represent frequencies or percentages or cumulative frequency or cumulative percentages. It really helps us compare different distributions of how things lay out. Now, a frequency distribution table can be displayed in both graphs and can be displayed in tables, and it can be grouped or ungrouped based on what type of information you're looking to convey to someone else who's trying to interpret the data. Scattergrams demonstrate the relationship between data by gathering multiple plots on one XY axis. It helps you get visual display of the relationship between a bunch of different variables. So picture an X and a Y axis and all these different dots. And when you throw all those different dots on that graph, it really helps you show where the concentration is for different variables. Now, a pie chart represents parts of a whole, right? So the whole pie equals 100%. And it's pretty much the most acceptable with general audiences. Most people are very acquainted or well-versed in understanding a pie chart because they make the assumption that it's out of a whole, out of 100%. So the percentage represented by each part of the pie should be labeled to create clarity. You don't want to create assumptions or water down the data based on that. So make sure that it's labeled clearly. Now let's just briefly talk about inferential statistics. Inferential statistics allow you to infer what may happen with a population based on a smaller population. Remember, the more patients that you have enrolled in a study, the more likely you are to be able to generalize that across a population. So you want to infer what may happen with the whole population based on a smaller population. And we have what's called a confidence interval. You want to make sure that your confidence interval is 95%, which means that you are 95% confident that you are right in what you are inferring is actually correct. This is used to test a hypothesis. So another term that you have to understand is statistical significance. So statistical significance indicates the results found in the analysis of the data to be unlikely or to have been caused by chance. More likely, those results have been caused by the independent variable. There's another term that you have to understand. Now, another term that you need to understand is called a t-test. T-test is a statistical hypothesis test that's used when you are comparing the statistical difference between two mean scores. So hint, the T stands for two. So t-test is comparing two. ANOVA is an analysis of variance. This is used when you are comparing the statistical difference between three or more scores. So the t-test is for two and ANOVA is for three or more. Now, the data, once you've gathered it and you've done the comparison, that would be presented in very complex tables. Now, there are multiple types of ANOVA tests. There's one-way ANOVA, two-way ANOVA, and multivariate ANOVA. Another term that you have to know is degrees of freedom, DF. The degrees of freedom is the number of values or observations that are free to vary when you are comparing different statistics. It represents the number of measurements taken, one for each population, and the number is necessary in order to interpret the inferential statistical test. Remember, you are inferring what may happen with a population based on a small sample size. Now, the other thing I just want to mention is p-value. Now, p-value is an important thing that you want to look at when you are reading research or new evidence-based research that's just come out. The p-value is that number that tells you that how likely it is that you came to a false conclusion. The smaller the p-value, the more significant the results. Now, the standard acceptable p-value is 0.05. Now, keep in mind that that correlates very closely with your confidence interval. Remember, I told you the confidence interval has to be 95%, which would mean that an acceptable p-value is 0.05 or less in order for your confidence interval to be accepted. I hope that makes sense. Let's talk about central tendency. So what is central tendency? It's a measure of telling us where the middle of the data lies or the clusters of numerical values. It's basically the frequency distribution plotted on an XY graph, and the resulting graph will give you a representation of three common measures, which we'll talk about: the mean, the median, and the mode. The mean is the most common measure of central tendency. It is very sensitive, though, to extreme values. It's considered the most useful, commonly used, and stable measure of central tendency. So each number is considered according to its value. So example, if you have a set of data, you add all the numbers and you find the sum, and then you divide the sum from the number of data points, and that gives you the mean. The average, where is the central tendency for that? The median is a midpoint in the data, so it's the middle score in the data. And it's not affected by high or low extremes. It finds the exact midpoint of the data, which means you have 50% of the data above and 50% of the data below that median. It's used with ratios, intervals, or ordinal data. It is a little less stable as a measure of central tendency. The mode is the most frequently occurring score. It's usually the peak of the graph, right? So it's the easiest measurement to determine. It does affect the skew of the graph or the shape of the graph. So the skew is when the central tendency scores are not uniform. There's a skew. In a positive skew, there's more numbers that fall into the lower range. So the mean is greater than the mode. And in a negative skew, more of the numbers fall into the higher range, meaning that the mean is less than the median. Let's talk about the measures of dispersion. The measures of dispersion describes how wide or dispersed the scores are around a central point. It's in a normal curve, think about that normal bell curve, the central point would be the mean, median, and the mode. So the range difference between the highest and lowest scores of a data set is affected by extremely high or extremely low scores. The width of the curve determined by the measure of dispersion. So if you took a test and there was a wide range of scores all the way from very low scores to very high scores on the test, the bell curve would be lower and wider. And if you took an exam and almost everyone in the class got a 75, you would have a very short but high bell curve, meaning that that measure of dispersion is very, very short. The standard deviation represents the square root of the sample variance. And this is a more commonly used measure of dispersion, and it reflects the range within the matrix. So for example, the bigger the range or standard deviation, the wider the curve. So the bigger the range of scores on that test, the wider and shorter the curve, the standard deviation. Now in research, you want to have the smallest standard deviation as possible. I hope this brief review of biostatistics was helpful for you and helped make sense for all that you need to know to put biostatistics to work for your research projects and your board exam. Some of those case studies might involve some biostatistics. If you need additional resources or help with biostatistics and understanding the content, I have put together some study guide sheets, and you can click on that link in the show notes. I would invite you to ask any questions at all that you need answered. Sometimes questions come up when you're listening to this podcast. If you have a question, most likely someone else has the very same question. I'd be happy to answer it and would probably share it in a future podcast.